Okay, graph the function, identify the domain and range. So, y equals x to the second minus 3. So let's just focus in on your parent function. Parent function means it's just y equals x to the second power. Okay? So, I'm going to put 3, 2, 1, 0, negative 1, negative 2, negative 3. Now, what would happen if you just took 3 to the second power? Okay? I'll just put x to the second under all these. Kind of like we did before. I'm not going to worry about the minus 3 till after I figure out what the x to the second's equal. So if I put a 3 in for x, 3 to the second power means 3 times 3, and that's 9. Okay? Now I'm going to jump down here and put negative 3 to the second. So negative 3 to the second means negative 3 times negative 3, which is also 9, positive 9, because a negative times a negative is a positive. Okay, 2. 2 to the second, so that means 2 times 2, and that's 4. Now, negative 2 to the second, so negative 2 times negative 2 is 4. Okay, now I'll put 1 to the second, okay? So 1 to the second, 1 times 1 is 1. So looking at what you have, you want to take a guess at what happens when you put negative 1 to the second. That's also 1. Now 0 to the second is 0, and that is your parent function. Now you have an operation with the x to the second of a minus 3. Now put that in parentheses, the x to the second. That's outside. It's not in a parentheses with the x to the second, so that's a k value. It's outside the function. So if it is outside, it does the same operation or the same effect to our y's, all your y outputs. The x's stay the same because inside that parentheses I made, it's x to the second, and that's it, okay? So I'm just going to minus 3 to all my y's. So 9 minus 3 is 6, 4 minus 3 is 1, 1 minus 3 is negative 2, 0 minus 3 is negative 3. Now I just did 1 minus 3, I got negative 2. I did 4 minus 3 earlier, I got 1, and now I do 9 minus 3, I got 6. Now look at your outputs, okay? It's like you take 3 to the second, which is 9, okay? Then you subtract 3, you get 6. Okay, so this is x, this is y, so we have 3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. 2, 1. 1, negative 2. 0, negative 3, negative 1, negative 2, so now I go left 1, down 2, okay, and then negative 2, 1, and then negative 3, 6. Okay, and there's my parabola. Now it's continuous. You can put decimals in for x too. Like you could put 2.5 in, you could put 2.3 in, so to represent that, you draw a continuous connection with arrows because the x's go on. Now the domain is all, okay, because x, you can put any number in for x and take it to the second power, but there's only a select set of numbers that the y could be, starting with your vertex, okay. This here, this middle point's known as the vertex, V-E-R-T-E-X. The vertex is at middle point, 0, negative 3. Now, put your y with its value there, negative 3. Now from there, these numbers are bigger than negative 3, okay? So the y is always bigger than negative 3, okay? It's equal to negative 3, but it's also bigger, greater than, so it would eat the y, okay, as your range. Okay, y equals x to the second plus 5, okay? So again, we're just going to go off that same parent function, just put the function down for y equals x to the second power, okay? So 3, 2, 1, 0, negative 1, negative 2, negative 3. Now put those same numbers to the second power. 9, 9, 4, 4, 1, 1, 0. Okay? Again, you're taking them to the second power. 3 times itself, that's what a second power is. 2 to the second's 2, just like I was showing over here. I'm just not going to do that every time because we already know, we figured that out. Okay? Now, Put a parentheses if you don't have one around just your x second. So that's another k value. And remember, that's outside the function, outside the x's second, does the same operation to y. Okay, so plus 5, x stays. So 9 plus 5 is 14. 4 plus 5 is 9. 1 plus 6, 0 plus 5 is 5, and then we're just back to 6. I mean, think about it. 1 plus 6, 5 is 6. 4 plus 5 is back to 9. 9 plus 5 takes us to 14. Okay? Because if you substitute 3 for x, 3 to the second power is 9, but add 5 is 14. If you substitute 2, 2 to the second is 4. 2 times 2 plus the 5, though, is 9. Okay, now x, you're good to go by 1s, but the y's you have to get to 14. So on the y-axis, we're going to go by 2s. Okay, so 3, 14, 1, 2, 3, 2, 4, 6, 8, 10, 12, 14. 2, 9, 1, 2, 2, 4, 6, 8, and then 9's between the 8 and the 10. 1, 6, so here's 1, 2, 4, 6. Then 0, 5, 2, 4, and then 5. Negative 1, 6, 2, 4, 6. Negative 2, 9, 2, 4, 6, 8, 9's right there. And then negative 3, 14. 1, 2, 3, 2, 4, 6, 8, 10, 12, 14. Okay, and there's your parabola. Now it's been moved up because we're adding. Okay, from the middle it moved up. Okay, label your vertex point. Just look at your middle point, 0, 5. Don't count squares because a lot of times you're going by 2's. Just take your middle and label it. Okay, so the domain's all. Now the range is restricted, starting with 5. Now look at all those other numbers on your table. They're greater than 5. Okay, so greater than or equal to 5. Okay, next one, we got y equals the quantity x plus 4 to the second. So again, I don't have to put my parentheses because it's already there. So set up your parent function. Same as before, okay? 3, 2, 1, 0, negative 1, negative 2, negative 3. Now if you're wondering, again, what I do with those, just pretend it's y with x to the second power. We're going to ignore the plus 4, okay? So 9, 9, 4, 4, 1, 1, 0. Again, I'm taking those numbers times themselves, which is what, if you put a number in for x and take it to the second power, that's there. Now, but we have a value. We don't make a parentheses like I did on the first two because there's already a parentheses. This plus 4 is inside the parentheses, so it is an h value, okay? Inside in the parentheses with this inside of the second power function, if it's inside, it does the opposite, not the same, the opposite operation to the x, okay, to the x, not the y. So plus 4, I go to the x column. If I see plus 4, I need to minus 4. And the y's, I'm not doing anything because there's no k value outside. 2 is, the second power is not a k value, okay? Second power. If there was a plus 6, I would be calling that a k, but it's not. 3 minus 4 is negative 1. 2 minus 4 is negative 2. Negative 3. 0 minus 4 is negative 4. And they do not come back around on the x. Think, negative 1 minus 4 is negative 5. Negative 2 minus 4 is negative 6. Negative 3 minus 4 is negative 7. Now the y's are going to stay the way they are because there's no k values. Okay? Okay, so negative 1, 9. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 2, 4. 1, 2, 1, 2, 3, 4. Negative 3, 1. 1, 2, 3, 1. Negative 4, 0. That's an x-intercept. Okay, it's also my vertex point. Negative 5, 1. 1, 2, 3, 4, 5, 1. and then negative 6, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, and then negative 7, 9. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And there's your parabola. Okay, so label your vertex. That's the middle. All you got to do is look in the middle of your table. That's the negative 4, 0. Now the domain's still all. Now you put your y with its middle value 0, and you see, okay, all these other numbers are bigger than 0, so it's greater than or equal to. Okay, then the last one. So again, anytime I see the x with the second power, I'm just going to jot that down, and that's how I start my table. All the other operations of minus 2 to minus 6, will deal with those after the parent table has been created. 3, 2, 1, 0, negative 1, negative 2, negative 3. So 3 to the second, that's 9. It's not 6. That's 9. Negative, again, here's why they're both 9. Because if I put a 3 in for that x, 3 to the second means 3 times 3, and that's 9. Okay, so when x is 3 in this one, y would be 9. It's not going to stay that way when I look here, but now negative 3, if I put negative 3 in, negative 3 to the second means negative 3 times negative 3, and that's also 9. A negative times a negative is a positive. I don't care what the caret key says. 2, 4, 4, 1, 1, 0. Okay. Now, we got x, we got the second power. What else we got? We got that minus 2 inside the function. Okay, that's an h, and we got the minus 6 outside the function. That's a k. So remember how these work. We got inside and outside this time. So the inside does the opposite to the x, the opposite operation to x. Outside, minus 6, that does the same operation to y. Okay. So inside minus 2, that does the opposite to the x. So I go to the x, but we switch that to plus 2. Outside does the same to y. So we go to y, but we don't make it plus 6, we make it minus 6. So 3 plus 2 is 5, 2 plus 2 is 4, 1 plus 2 is 3, 0 plus 2 is 2, negative 1 plus 2 is 1, negative 2 plus 2 is 0, negative 3 plus 2 is negative 1. Now, 9 minus 6 is 3, 4 minus 6 is negative 2, 1 minus 6 is negative 5, 0 minus 6 is negative 6, okay? 1 minus 6 is negative 5, I just did 4 minus 6, and that's negative 2, 9 minus 6 is 3. Now, to prove that to you why that works the way it does, let me use this scratch paper, okay? Let's replace 3 with y. I'm going to write that function. I'm going to replace my y with 3 and my x with 5. So we know the value of this side's 3. Now the other side, you use your please excuse my dear Aunt Sally. 5 minus 2 is 3. So I have 3 to the second minus 6. Now I do the exponent. That's 3 times 3, and that's 9. So this is replaced with 9. And then 9 minus 6 is 3. So 3 equals 3. That's why. And if you did it with all these other numbers, the same thing would happen where you have the same value on each side. Identity property. Okay, so 5, 3. 1, 2, 3, 4, 5, 1, 2, 3. 4, negative 2. 1, 2, 3, 4, 1, 2. 3, negative 5. 1, 2, 3, 1, 2, 3, 4, 5. 2, negative 6. 1, 2, 3, 4, 5, 6. That's your vertex point because that's the middle. 0, negative 5, 1, 2, 3, 4, 5. 0, negative, excuse me, I screwed that up. It's 1, negative 5. 1, I'm down here, okay. 0, negative 2, so that's a y-intercept. It's on the y-axis. X being 0 means it crosses the y-axis at negative 2, then negative 1, 3. Okay, there's your parabola. called a quadratic function. Now you label that middle, because that's how you interpret your domain and range. Domain is all possible values for x, range is all possible values for y, okay? So 2, -6. But see, with arrows on each end, I could put anything I wanted to in for x and take it to the second power. So domain is all, okay? Now the range is your possible y, just put x equals all. Now the range, you take that vertex -6, and range is not all, because clearly that's a low point, okay, for your y on the up-down part. What do all the other y outputs have in common? Well, they're all greater than -6, okay? Clearly see that. So, greater than or equal to -6.